So we're just a little warm up on this crazy lesson today. All right, so we FOIL fast. This was x plus 3 or 5 cubed. So I just wrote it as squared and squared first. Blah, blah, blah. Who cares? All right, so next, we're going to hold some stuff in our head. I know that's x cubed. All right, that's what I'm going to hold in my head. 5x squared and 10x squared. That's 15x squared. If you don't want to do this, that's fine. If you want to write them out and then do an extra combined like term step, good. Um, but if you can handle this, you're mathematically inclined, numbers. I just yelled at my daughter Brianna yesterday because she was doing she's in the geometry honors that I told you about. She was using her calculator for basic multiplication. And I slapped the calculator out of her hand. I go, that is why you cannot and don't remember your times tables. And the students that I have in class don't know their times tables because they just sit there and press buttons and don't even think mathematically. Anyway, all right, so 50x and 25x. I didn't slap her. I just, don't say, I'm saying it metaphorically. I said, no, do not. All right, and then the last one, I lost that line. 5 quarters to lunch people would be a buck 25. So 125. Okay, so taking a binomial cubed, it's doable. It's not that bad. Um, it can be done and it takes a couple steps, maybe a couple extra if you want to combine like terms. Hey, let's go past all of this. What the heck is it? What? Oh my goodness. And then let's look at the notes and just look at it real quick. So would example 1 be hard? Yes or no? Don't look at all the blanks, but would that be hard to cube that? Yes or no? No. Would it be hard to take this to the fourth power? It's doable, but don't you have, like, after you did it to the third power, you'd have to go one more time, right? And then multiply by another binomial. Doable? Now it's getting a little ridiculous. Come on. Would that be very hard or not, writing this out and multiplying so many times? You'd have 5 stages. You'd have 5 stages. You'd have to square, then you have to multiply that by the next binomial, then by the next binomial, then by the next one, and then by the next one. And I think you understand at that point, this is getting out of control. That question alone to take to the sixth power would take a half hour, maybe 20 minutes. Even if you were good at it, you have to be careful. There'd be so many steps. You'd have to, a mistake would more than likely be made. So there's the selling point about what all of this is. There's actually patterns that develop, and therefore we can use what I might call a formula to actually take a binomial to the sixth power and do it faster. And there's the selling of the notes. Okay, I think this guy's name came up. He was one of the big hitters in our probability movie. Remember that? It was Pascal, and I think maybe Blaze, or maybe he was another person. I've watched that so many times. I just have a hard time with remembering names and where they get placed. But I know Pascal was one of the big hitters in probability. That little thing about flipping coins. Well, he's done a lot of things mathematically. This one's a strange one, and you can feel free to read all this. It's all great. He created something called Pascal's triangle, which good for him. What does this have to apply to? And it actually has applications in a few different things. It's awfully strange. So first, let's look at this. And all it is notice we have ones on the diagonals on the outside of the pyramid. Then the next row is 1, 1. Okay, that's not really anything. Then the next ones, now things start getting created. Like, how do we get 1, 2, 1? Well, 2 comes from 1 plus 1. The previous row above them, the two numbers that is 2 is in between. So look at this next row, 1, 3. That 3 comes from 1 plus 2. So weird, all right, that this is created this way. So this is, don't worry about the C's for a second, the fifth row. So everyone, we could do this. What's the sixth row? 1, and then what's the next number? 5, 4, 3, 2, 1. Say it. 6. What's the next number? 5, 4, 3, 2, 1. The next one, 5, 3, 2, 1. No. 20. And then what? 15. And then what? 6. And then what? Okay, so we at least know how to, draw out Pascal's triangle. Here's the problem, though. Say I needed to use Pascal's triangle, and I needed the 11th row for something. What would I need to get the 11th row? The 10th row. But wait, what would I need to get the 10th row? The ninth, where would I have to go? All the way to the beginning and construct this and keep doing that. And it's not very user friendly in that case. Am I right or am I wrong? That's called a recursive like definition. You may find that out next year when you do no, wrong. When you do sequences and series. I think you do have that next year. And a recursive definition is not good. It means in order for me to get to here, I have to have all of the previous stuff in order to get it, which is not very useful. We need what's called an explicit definition. We need a formula that gets me that stuff right off the bat. And oddly enough, what that formula is the glory and power of combinations. Accidentally, through combinations actually give me direct rows of Pascal's triangle. Get out your calculator. We're going to test this. I'm actually going to show you and you don't even know the connection yet. You're like, wait a minute, okay, why the heck are we talking about Pascal's triangle? I'll show you the connection. It actually does help us um, multiply binomials fast. At least take binomials to powers. Okay, so first thing, get used to where your combinations button is. And I'm gonna emulate row 5. So we're gonna get row 5 and we're gonna type this out and show how that gives me the 5th row of Pascal's triangle. All right, and then I'm gonna talk about the binomial connection after this. So 5, wrong. I have an upgraded calculator. Unupgraded calculators, you type the 5 first. Now pay attention because I did have someone miss the very first thing that was said about what button I press next. 5. Okay, now in this position, stop. I don't want to do 5C0, press enter. 5C1, press enter. 5C2, press enter. I'm going to show you a way where you can get them all at once. It's not parenthesis, though. This is what the student missed last hour. It's second parenthesis, which is brace. See, braces in the graphing calculator, that means it expects a few numbers after this. It's a nice little feature. And then this is how you type it: 0, 1, 2, comma 3, comma 4, comma 5. And then you don't necessarily have to close. The graphing calculator is always nice. You never really have to close your grouping things. But this is what it's going to do now. It's going to do 5C0 through 5 now for me and put it as a list. Watch. Press enter. Boom shakalaka. Isn't that row that you see on your notes? 1, 5, 10, 10, 5, 1. So there's your formula. Now to get the 11th row, I can just do 11C0 through 11 and press enter, and I will get the 11th row. Does that make sense? Okay, so there's a difference between, try to remember those terms next year: recursive and explicit. Explicit is a formula that gets me the answer right away. Recursive, I need to write it all out and have the previous row to get to the next row. It really is a term in math that is works. Okay, so then what the heck is the connection here? All right, you're gonna have to have a leap of faith, and this is probably what my bell work should have been. I probably should have put up at the top like a plus b raised to the third. And then what we would have got was 1a cubed plus 3. Look at Pascal's triangle, 1, 3, 3, 1. If I would have had a plus b cubed, it would be 1a to the third plus 3a squared b plus 3ab squared plus 1b cubed. Magically, the Pascal's rows, those numbers end up being the coefficients in front of that multiplied cubed. And then look at a plus b to the fourth and accept that this would be the answer. If we were going to write a plus b times a plus b times a plus b times a plus b, worked out all the foiling, this is what the answer would have been. And mathematically, the coefficients in front is the fourth row of Pascal's triangle. And there's the connection. Okay, and then you just have to accept that and now just use it the rest of the way. Got it? Are you with me? And understand what it takes the place of actually multiplying out and all that foiling. So let's go back up to this one and let's do this one a different way. And you may not have room for this, but this is why I put this underneath, because now I'm going to do this using the idea of Pascal's triangle. But it's a little weird because the problem is I don't have a plus b, I have x plus 5. 5 is a number that actually changes the coefficients. So this is how it's going to work. Here it is. You're going to have 4 terms, and the first thing I do is I put the Pascal numbers there. All right, this is kind of like, this is how it happens. This is how it works. And then I'm going to just go ahead and move on from there. All right, the first term is the Pascal number, and then it's times the first term x, and x raise it to the third power. This is the schematics of how this is going to work. Take the 5 and raise it to the 0. By the way, what's anything to the 0 power, including coefficients? 1. Now, notice the successive terms. This goes down 1. This goes up 1 in power. You see that? So the first term, it goes down by 1. The second term, the power goes up by 1. Then you'll see how this answer results doing this a completely and totally different way. Down 1, up 1. And then notice the last term. Down 1. What's x to the 0 power again? 1. No one said 1x, and you shouldn't have. Anything to the 0 power is 1. So look at this first one. 5 to the 0 is 1. This is 1 times x cubed times 1, which is x cubed, equal plus, this is 3 times x squared times 5, which is 15x squared, plus 5 squared is 25. This is why you don't see Pascal numbers on this as a final answer. The 5 changed the coefficient. Hopefully you know what coefficient means, number in front of. And then the last one is 1 times 125, which is 125. Then lo and behold, we did this a completely and totally not even same way, and I have the same answer. That's the power of Pascal's numbers and this little thing of pattern recognition. This is really what happened. It's pattern recognition why someone came up with this binomial theorem. That's what it's actually called. Taking a binomial to any power can be done this way, all right, because of pattern recognition. Again, look at the pattern recognition here. Look at the powers on A. The powers on A all go what each time? What do they go? Down by how much? 1. And then the powers on B, up, 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 go up by 1. So this is how someone recognized that in the other parts. And then they just recognized these patterns when they were foiling these out over and over and over again. The coefficients developed a pattern that was Pascal's triangles pattern. Very strange, right? And that's what we do as mathematicians. We see these patterns, and then we use them. Okay, so you could argue for a cubed, which way is faster? I think actually cubing would be faster. But let's go through the process. Here's how it starts. On this thing, it's 3C0. Even if you screwed this up and did 3C3, you know 3C3 is equal to 3C0? You notice that? Right? They both equal 1 because the triangle's ends are 1s. So even if you mess this up and did 3C3, 3C2, 3C1 in reverse, you would still be okay. But you would screw up other things if you did that. So just make sure it starts with 3C0. So this is how I do. I put each part and take care of each thing first. And we'll go to the calculator later on this. All right, and then P, what do I raise that to? To the 0 or to the third? Which one is it? How does that start? I mean, think about it if you were going to FOIL this out. You'd have P times P times P in the first position. It'd be P to the third in the first spot. And that's what this is emulating. All right, this is very important. -3. You must make this plus a negative. And understand that -3 goes in this little pattern recognition thing. All right, I did not have that in the first one. That's to the 0 power. And then after that, it's easy. P squared. This is how I did it in the notes last hour. Did all the P's first, and then I did all the -3s second. Just thinking about what people do when they screw this up. These are 3 things multiplied here, not added or subtracted. Okay, so these are all products. Sorry, didn't finish that. Product, product, then plus, product, product. So these are how you get this term. You got to multiply these 3 things together. Okay, so accomplishing Pascal's triangle. Here's what I'm going to do. I'm going to do second entry. You're going to go way faster than me. My computer is very bogged down. It doesn't mesh well with this calculator. So I have to do like one arrow over at a time. I guarantee you're already done. I think this is easier than retyping it and trying to find the C. Just doesn't look that way because of my calculator. 3C 1 through 3. So you got to get rid of the 4 and the 5. That will definitely give you a calculator error if you leave that 4 and 5 there. That's doesn't work. Press enter. I know you can look at Pascal's triangle for the small ones, but I just want to emulate again that you see the third row is 1, 3, 3, 1. Okay? But anyway, that's 1. And then that's times p to the third. What's anything to the 0 power? What's anything to the 0 power? Okay, because if I get people writing -3 there, that's why you're getting your answers wrong. It's on you, nobody else. 3, 3, 1. Sorry, I should have wrote those down as I saw that on the calculator. And then p squared, -3 to the first. P to the first, or just p, I should have just left that there. And then it's on you if you can't square a negative and get a positive. All right? -3 times. That's the button pushers. Was it me? Was this the class I told you about my daughter and slapping that calculator out of her hands because she's doing basic math with calculators, which makes her brain atrophy, and then she can't do her times tables anymore? Arr! What's p to the 0? 1. Not 1p. No one said that. Okay, but it's 1. Anything to the 0 power. Then negative times a negative times a negative is a negative. All right, and then you multiply these and get p to the third. Watch what I do next. This is a negative, so I do like making that a minus sign. So -3 times 3 is -9. Make it -9p squared. You can make it plus a negative, it's fine. All right, but I like making it minus. And understand that the signs alternate. 27p and then minus 27. So you could argue cubing this might have been faster than going through this process. It's a valid argument, probably. But then your argument goes out the window on the next one. So I don't think you could take this to the 4th power as fast as I'm going to do this. And then what ends up happening is there's a lot of room for error when you're foiling. Like that, you might miss a negative in one of them. All right, and then the whole thing is screwed up as you keep multiplying. Okay, so 4C, what does it start with? 4C what? 0. And then 4C what? 1, and then 2, and then 3, and then 4. It does take some time, but I find it peaceful. It's like, okay, I get it. I get the pattern. All I got to do is be nice and write it all down. It really isn't that hard. All right. And then, I have 3x. So it's 3x raised to the 4th. And it's -2 raised to the 0. Remember, plus a negative. -2 is the thing that goes there. And then 3x powers go down. You do whatever you want. If you want to go ahead and do the 3x's and all their powers, and then go back to the 2, and this should always end in a 0, just like the -2 should end in this case, to the 4th. And then you're going to see some more pattern recognition when I actually simplify the kind of question you might be asked. Okay, and then I didn't go to my calculator. You could go, you could use your notes. If it's a Pascal row that you have, then just look at the row. All right, but it is good to know. Yeah, on a test, you don't have Pascal's triangle, so you are going to have to do this. Second entry. Oh, I don't know about those scientific calculators. You know what? Scientific calculators do have braces as well. I think you're able to type this exactly the same way. Does anyone have a scientific on them? A scientific calculator. After I'm done with the notes, I have one in my cabinet or in a drawer here. I might check that one, and I think it does. 4, and then yes, the comma is it's right next to the x squared or below sine. Remember sine? Second insert or that too above the 7. Got it honed in here. We got it surrounded now, right? All right. All right, and then enter. But you can have flipped on the other page and saw 14641. Right? So 1 4 6. Notice how that happens. Once I get 146, then it ends 4 1. Right? That's easy. And actually, I could calculate these 3 to the 4th. Please be ready to use your calculator and be better than last hour. That's right. I said it. I'm sitting here like a moron. Hey, what's that times that times that? And we're just like this. I'm not doing anything for you, Mr. Samuelus. They did make that noise. All right. And then 3 times 3 times 3 is 27. And then negative 2 to the first is negative 2. I might need that calculation. 3 squared is 9. And then negative 2 squared is 4. Wasted a lot of time in the notes last hour because I couldn't get help from anyone. These kids these days. What's anything to the 0 power? 1. That's how that 3x disappears. There is no x term. There is no x's in that term, I mean. Then negative 2 to the 4th is a positive 16. Daughter, right? You should know that. Where did you get that 16 from? Stop touching those calculator buttons so much. And then this is an alternating one again. Plus, minus, plus, minus. Okay, here we go. What's 27 times 4 times 2? Ooh, we have some help. You know what? Now I remember from last hour. 216, x to the third. Yeah, it's negative. We have the minus. I think the next one's 216. Yeah, that now I have a recall. 4 times 12, 96 negative. Is that right? X. Then the last one is just plus 16. If I had someone foiling away, they would not be done yet. Guarantee it. Once you get good with rightness, it is not too bad. Next one. All right. It's going to be a pain. It's easy, but it is a pain to write all these things out. Okay. So just understand that, yes, there is a process that needs to be written, but it is not that bad. I'm going to take care of the C's first. 6C0. This also tells you how many terms you have. So the notes, I was nice enough to give you blanks here. But doing this first tells you when I take something to the 6th power, I have 7 terms. All right. And then when I was constructing these notes, because I was kind of messing around with some old notes and changed a little bit, I knew how many blanks I needed, all right, when I made up the blanks. So it's just something for you to think about as well. Okay, yeah, this is going to get nuts. So this is 5x raised to the 6th negative 3y. I don't know why that disappeared. Raised to the 0. And then go down, go up. Kind of didn't give you the perfect amount of room for this, but it's good enough. 5x to the 4th. Really enjoy this. This is like the crux of math. This is what mathematicians do. They find patterns and stuff. And then once they get that down to a formula, then they use it as a formula for efficiency. And that's what math is really all about. Really is a big efficient thing, getting stuff done. All right, for some reason I'm writing, I think in the other hour I zoomed in more, that's why. And then I started writing these real small. 5x to the 1st, negative 3y to the 5th, and then the last one to the 0 and to the 6th. Okay, please be a pal and help me out on these. I think I'm not okay. What's so this is oh yeah, I gotta go to my calculator. Let's do it one more time. All right, so second entry. I don't know. I feel like this is fast. It would be faster if my calculator computer wasn't so slow working together. So I got to do one arrow at a time. Otherwise, I kind of like just keeps going and goes crazy. 6. Was this the row that we found? Didn't we find the 6th row from the 5th row? But you understand my point. And actually, my last examples, you can see we don't have those rows. So second insert. I don't know if I said that. That's how I'm adding these numbers. And now that I'm in the insert feature, it just stays until I arrow out of it. So second insert allows me to do that. No, notice a pattern. 1, 6, 15, 20. And then what happens? 15, 6, and then 1. All right? Because that's how this works. So 1, 6, 15, 20 is all I have to remember. 1, 6, 15, 20, and then it goes back down. 15, 6, and then 1. And then back to this. Who did 5 to the 5th? 6, 6, 6. What's 5 to the 6th? 15,625. Holy cow. X to the 6th times 1. What's 5 to the 5th? A little bit smaller than that. 3,125. I'll be able to get the next one. X to the 5th. Oh, and now I have a negative 3y multiplied by that. Again, you multiply those. I'm thinking of some crazy answers of people. They end up with 25 terms in here because they do 1 plus this plus my. And it's like, oh, you have no connection of what we did here. And there's nothing I can really do about it except Mark, you totally missed something. And then negative 3 squared is 9 y squared. I feel like I did so much better with spacing in the other class, but 125x cubed. This is a tough one. This is why I really like the next questions. But I really need to do this one so you recognize some more patterns so that how the next questions are actually easy. All right, I will have you calculate this when we get to this. Negative 3 to the 4th is 81. So I can do that. And it is y to the 4th. And then 6, I don't have space for the pluses, but maybe I should squeeze those in there. These are the separation of terms here. 4, 5. Thanks, Pen. It's stupid. 5. Oh my gosh. 5x. And then is that negative 243? Y to the 5th. So it takes time, but it's not hard. Just takes some time. Now, what's 3 times another 243? What's 3 to the 6th power? I guess I should have remembered that, but even doing this last hour. Okay, now I need your help again. Not on the first one, though. 1 times this time, it's 15,625 x to the 6th. Minus, I did the old minus other term. What's 6 times 3125? 3125 times 3. And it's minus because there's a negative in there, x to the 5th, y. And then even if you miswrite something, look at the powers on x. They go down by 1. The powers on y go up by 1. So you should double check that. All right, 15 times 625 times 9. Still a big number. Can we get a confirmation on that? X to the 4th, y squared. Good. And then 20 times 125 times negative. So it's a negative. I'll put the minus. Still big numbers. Waiting. Plus, still some big numbers. 15 times 25 times 81. All it takes is a calculator. Not hard. Just got to punch the buttons. Say that again. 375. Confirmation. Okay. I assume you just speak up if there was a contradiction. I could do 6 times 5, 30. What's 30 times negative 243? 2,430 added to itself 3 times. 72.9. What? Say it again. 7290. Okay. And then x y to the 5th. And I think I have the last one. Yep. Plus 729 y to the 6th. Okay. So it's still way faster than taking that to the 6th power. If you had to write that out 6 times, you'd have 5 multiplications. The first one would be a FOIL. Then you'd have a trinomial times a binomial. Then you'd have a quadrinomial. Did I just make up a thing? But a 4-term polynomial times a binomial. And that would keep going. You'd have to do 5 multiplications. You'd still be in the middle of that right now. And all the possibilities for making an error in your foiling. There are so many things that you're doing there. You may make one mistake somewhere in the middle. The whole rest of the question's jacked up then, because you will never get the right answer if that was the case. So imagine before walking in, seeing this, you'd be like, oh my gosh, you'd faint. This is what we're doing today. I really don't think it's hard. You just got to be organized. All right. And that's it. So, hey, let's do some pattern recognitions. So look at what this is. This is considered the first term, right? How many terms are there in this raised to the 6th power? How many? 7. First term, second term, third term, so on and so on and so forth. This is why I love these questions. These questions are perfect for, okay, if I expanded this, that would be nuts, man. It would still be a big bugger of a problem. I have 11 terms with all these C's and huge numbers and all this other stuff. But if I just want the 5th term, this is all I have to do. So what's the 5th term here? It starts with 6C what? Everyone say it. 6C what? 0, first term. 6C1, 6C2, 6C3, 6C4. That's the 5th term Pascal number, right? So what's the 5th term here? What do I start with? What number in the C? Look at the power. What number do I start first on the C? 10, 10 C, and then 10C what? 0, 2, 3, 4. So the very first thing you do is, okay, that's my 10C4 from the Pascal triangle list. That's the 5th term, what helps me generate the coefficient. Well, now it's over. Since I've shown you what happens, we know we have 3x raised to a power, and we know we have negative 2y raised to a power. That's how all these terms were generated. Okay, notice this. I'm going to get a highlighter. Uh-huh. 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 I think I'm done. What power goes on negative 2y? If you don't see 4, you have an inability to see simple patterns. Right? Okay, and then let's go back up here. What's this plus this? What's this plus this? What's this plus this? What's this plus this? What are all those answers? 6. Okay, so then what's the pattern on this? 6, because 6 plus 4, everyone equals what? 9. Oh, 10. All right, so then now all we have to do is go to our calculator. I don't need that big thing there. I could just do math PRB, and I don't have to do the whole list. I just have to do 10C. What the heck? Oh, I frustrate myself sometimes. That was not the computer. You're okay this time. You stink every other time. Oh, I'm sorry. Very angry at my computer and the pen and what I've had to deal with this year. And maybe it is COVID. Maybe the computer can get COVID too. Who knows? 210. And then what's 3 to the 6th power? Could someone do that? I don't feel like touching that computer anymore. Calculator. What's 3 to the 6th? 729. And then x to the 6th. And then negative 2 to the 4th. I can handle that one. 16y to the 4th. And then you can multiply. You can multiply numbers. Then you'd have to multiply these and then move on. Okay, got it? Can I move on? You know how to multiply 3 numbers on your calculator. And it's whatever that number is, x to the 6th, y to the 4th. Does anyone know what that number is, or should I just move on? No one's talking to me. Let's move on. Oh, these kids. Okay. And then I skip to 6 because I think the point's been made. Okay. So I want a coefficient, the coefficient of the x to the third, y to the fifth term. Well, that's weird. Okay, well, this is all you do. You know the thing. You know the thing. This is going to be 8 c something, right? So you know that. Don't say anything yet. And then I know I'm going to multiply that by 2x raised to some power and 5y, in this case positive, raised to some power. Well, we should already know the powers on the x and the y. What does this have to be in order to get this? 3. So what does this have to be either to get this or to satisfy this? It's both the same answer. 5. And then what is this now? That is 5 because of that highlighting that I did, with that always matches the second number on the C. That's it. And then everything else is starts with the C. Calculator. All right. And you don't need me for that anymore. All right. You should be able to do that and take this, get that, take 2 to the third, which is 8, 5 to the fifth, which is a number. I think we already had that today. Was that 3125? I think it was. So this is 8 x cubed times 3125 y to the fifth, and then whatever 8c5 is. Did anyone get 8c5? Did anyone calculate it? Huh? 56. And then let's go ahead and finish this one off. Just take this times that times that. And that's really the answer because all they wanted was the coefficient. But what is that? 1,000,004 on the dot, 400,000. Holy cow. That's a big coefficient. That's the coefficient. You don't have to write x cubed y to the fifth. That's the number in front of x cubed y to the fifth. So that's why it's called the coefficient. All right. So I hope you appreciate that. I really enjoy the binomial theorem. It's kind of a neat pattern recognition thing.